Good morning, dear students. So as we were doing the distance formula, exercise 2a, and up to 12th question we have done. We have to start from 13th question B1. Okay, so let's get started. A1 will be the homework for you. Okay. Okay, so first of all, I'm reading the question. Prove that the quadrilateral ABCD, whose vertices are 4 vertices are given, is a rhombus. Is it a square? Okay, so we just need to prove that 4 vertices are given to us, and we are asked to prove that whether it is rhombus or not. So let us recall the properties of rhombus. In rhombus, we know that all the sides are equal, but both the diagonals, they are unequal. And in the square, we know that as all the sides are equal, but both the diagonals, they both are also equal. They are mutually equal. Alright, so you need to remember, you need to know the difference between the rhombus and square. Being there, all the sides are equal, but you just have to see for the diagonal also. In the rhombus, both the diagonals are not equal to each other, but in the square, it is so. So here is the solution. Let us consider the vertices be A this one, B this one, C this one, and D this one. So the structure, let us consider the structure like this: A, B, C, and D. So let us find AB, BC, CD, and AD, and then we will separately find AC and BD. So as you can see that AB, BC, CD, and AD, this 4 I have found using the distance formula x2 minus x1 the whole square plus y2 minus y1. Like that I have done. I got root 5, root 5, root 5, and root 5 for all this 4. And separately I found the diagonals. Okay, and those diagonals I got as root 18 and 2. So as AB, BC, CD, all this are equal, and AC and BD not equal, so it is a rhombus and not a square because both the diagonals are not equal. So like this you have to give the explanation. Okay, so as if you see the 13th C1 and D1, in the 13th C, you are given with 4 vertices of a quadrilateral ABCD, and you need to prove that it is a rectangle. So how you will prove that whether particular structure is rectangle or not? Okay, so as we know that this side is equal to this side, and in the rectangle this side is equal to this side. Okay, and their diagonals are also equal. So if it is so, then we can say that it is a rectangle. And on the opposite, and on the other hand, if we talk about the parallelogram, so what can we prove in the, what we should prove in parallelogram? As opposite sides are equal, but its diagonals are unequal. Okay, this side is equal to this side, but it is not so in the parallelogram. So you should know the difference between these two structures. If you see the D1, 13th D, you need to prove that it is a square. I already told how to prove for the square. All sides are equal and their diagonals are mutually equal. So like that you can do D1 also. Okay, alright, so let us come to the 14th question. Find the circumcenter and circumradius of the triangle whose vertices are, we are given with the vertices of the triangle. We need to find circumcenter and circumradius. Okay, let us find this one. Okay, so here is the solution. Given 3 sides, so these 3 sides are there. Let us consider A, B, and C. So first of all, just try to understand what do we mean by circumcenter and circumradius. So circumcenter means in the triangle made by these 3 coordinates, if you make a circle which touches the 3 edge of a triangle, and the center of that particular circle will be called the circumcircle. Okay, and circumradius means whatever the see this OA, OB, and OC, it is called the circumradius. Okay, so this is called the circumcenter and circumradius. Now we have ABC. I'm considering O, the circumcenter, as XY, and I'm trying to find OA, OB, and OC. Yeah, AO, BO, yeah, CO. So AO will be what? x2 minus x1 का whole square plus y2 minus y1 the whole square. So x2 minus minus 2 the whole square plus y2 minus minus 3 the whole square. Minus minus plus here. Minus minus plus here. I have opened the bracket x square plus 4 plus 4x, and here y square plus 9 plus 6y. Similarly, BO, can you understand? X minus minus 1 the whole square and y minus 0 the whole square. I have opened here x minus 7 the whole square, y minus minus 6 the whole square. So x minus 7, the identity a square plus b square minus 2ab, and here also minus minus plus, so a square plus b square plus 2ab. As AO is equal to BO is equal to CO, because being a radius, all the radius everywhere it is same. Okay, so I'm equating this one, and this one, all the three equal, and I'm removing the root. Alright, so you just write root here, and in the next step please write this step after in the second step. Okay, because we can remove the under root if they are in equal. Now what we are going to do, we are going to take, first of all we are going to take these two, and then we are going to take this and this. Even you can take these two, any way you can go. Okay, you will get the answer. So but we are taking this one and this one. So taking first two side. So I'm writing this equation here after rubbing this, because there is no space available for solving the further solution. Okay, so I'm writing there. Okay, let us understand. So that equation I have written here, these three equations. So what I said, let us take first two parts. So taking first two sides, we are taking these two sides. So in this you can see that x square to x square, y square to y square cancelled. We are left with this 4x and 13, 4x, 6y and 2x plus 1. I have taken this 2x here. So 4x minus 2x, 2x. 6y as it is, and 1 is left here, so 13 will go that side, so 1 minus 13 minus 12. I've taken 2 common, so x plus 3y equal to minus 6. Give this as first equation. Taking last two sides, we get these two sides we are taken. X square to x square, again y square to y square also cancelled. What we will do, take minus 14x this side, so 2x plus 14x, 16x plus 1 as it is, 85 and 12y. Take 12y here and 1 that side, so it will be minus 12y and plus 1. It will go there and it will become minus 1, so 85 minus 1, 84. Take 4 common, so 4x minus 3y equal to 21. Give this as second equation. Now you have two linear equations in two variables, that is x and y. Using elimination method we have first equation is this and second equation is this. Multiply 4 with this equation just to make these two same. Okay, that is why I'm multiplying 4. So it will be 4x minus a plus 12y equal to minus ka 24. 4x minus 3y equal to 21 as it is, minus this minus plus, and here minus. This two cancel, 12y plus 3y, 15y, minus 24, minus 21, minus 45. So y will be minus 45 upon 15 minus of 3. Now you put in this one or this one, any one, you will get the value of corresponding value of x. So you got circumcenter as 3 and minus 3. That means you got O. Now you need to find either OA, OB or OC. Anything you find, you will get the circumradius. So find that thing. Alright. Okay. So question number B, what they are saying, find the point equidistant from the point. Sorry, I have written the wrong points. Wait. Yeah, these are the points. So we need to find the point which is equidistant from 1 to 3 minus 4 and 5 6. So if they are equidistant, okay, and from the same point, so we need to find that particular point. So one thing, it is very clear that if I ask you what will be the distance formula between these, you will tell me x minus 1 the whole square and y minus 2 the whole square. If I ask you distance formula between this, so x minus 3 the whole square, y minus will give you plus of 4. Okay, and what will be the distance formula between these two? X minus 5 the whole square plus y minus plus 6. So their distance are same because they are equidistant. So you can write these three equations. Now again, what you can do, this roots will be removed because they are in the equal, so root will be cancelled. Now what will be the second step? Open these brackets. Take first two sides and last two sides, and you know what you have to do, because if you have understood question number 14th A1, then you can easily do this B1, because you need to take two sides, and from there you need to get two linear equations and getting the x and y value which is required to us. Okay, similarly, if you see the D question, you need to find the center of the circle which is passing through, say for example, it is passing through the 3 points which is given 3 0. I'm considering random location. So minus 2 root 3 minus 1. So your circle is passing through 3 points and we need to find the center of it. We know if this is center and I consider this as A, B and C, OA will be equal to OB will be equal to OC. Why? Because radius. Okay, so you need to find, let's just consider this as XY. Find the distance formula between this one and this one and make all the three equal. Okay, you will get the answer of it. Okay, let us come to 15th question. The center of circle is 3p plus 1, 2p minus 1, and the circle, if the circle passes through the point minus 1 minus 3 and the length of its diagonal be 20 units, find p. Okay, so you are given with the center 3p plus 1 and 2p minus 1, and it is passing from one point, and I'm considering this point here. Randomly I'm considering A equal to minus 1 minus 3. Diameter is 20 units, so what will be the radius? 20 upon 2, that is 10 centimeter. Okay, now as OA, see this OA is the radius, so OA equal to 10 centimeter, and by using distance formula 3p plus 1 minus 1 plus 2p minus 1 minus 3 the whole square equal to 10. Squaring both the sides. We are squaring both the sides. Okay, so this minus will become plus. So 3p plus 1 the whole square plus 2p minus 1. This minus plus 3 the whole square equal to 10 square is 100. Plus 1 2, and minus 1 plus 3 will be plus 2 equal to 0. I've opened this bracket, I got this. Opening this bracket, I got this equal to 100. 9p plus 4p 13p square. 4 plus 4 8. 12p plus 8p 20 equal to 100. 13p square plus 20p, take 100 here. So 8 minus 100 minus 92 equal to. Now this is a quadratic equation. We need to factorize this equation, and we know how to factorize it. We have multiplied 92 and 13 first, and then we find the factors of that particular number and split this 20. So I'm directly writing the factors here. Okay, so please try to understand. 20p can be split as 46p minus 26p. Okay, so from these two we can take 13p common. So in the bracket we'll get 1 plus p plus 2, sorry, because we are taking 30p common, so 13p, p plus 2, and from this one we can take we can again take the wait, this won't be 2. Actually we should write this in terms of I've written reversed, in a reverse way, minus of 26p and plus of 46p, like this. Now you take 13p common, so inside what we will get, p minus 2, and from this you take 46 common, so p minus 2 equal to 0. Yeah, so 3p plus 46 and p minus 2 equal to 0. Now consider this bracket equal to 0. 13p equal to minus 46. or P is equal to minus 46 upon 13. And from here P is equal to 2. So we have two values of P, one 2 and another minus 46 upon 13, like that. Okay, now let us come to question number 16th. So it says that 16b1, prove that the points a, b plus c, b, c plus a, c, a plus b are collinear. As I have explained you the meaning of collinearity, collinear points are those points which are lying on the same line. Say for example, if this is the line and if these 3 points are lying on it, say for example A, B and C. So we call these 3 points as the collinear points. So let us consider A, B, C respectively. Let us name them. For collinearity, one condition you have to learn, you have to understand, AB plus BC should be equal to AC. That means AB plus BC should be equal to AC. If this condition satisfies, then we say that the points are collinear. Okay, so AB, let us find AB. So this is A and this is B. So okay, so AB will be what? X2 minus x1 the whole square plus y2 minus y1, c plus a minus b plus c the whole square. So this minus will go inside, so minus b minus c, and here we can see that c to c cancelled, so b minus a the whole square and a minus b the whole square we are left with. Now please understand this thing, this is b minus a the whole square. I'm taking minus common from this, if I do a minus b the whole square, I'm getting a square plus b square minus 2ab. And if I'm doing b minus a the whole square, I'm getting same a square plus b square minus 2ab. That means they both are same, no? Right? They both should be same. So how we are understanding, how we are claiming that thing, b minus a the whole square. I'm taking minus common inside the square only. I'm taking minus common. Okay, so I took minus common. So this plus of b will be minus of b and this minus of a will be plus of a. If you won't understand this, multiply minus inside. So minus minus it will be plus and minus plus it will be minus. The whole square which is going on. So it is actually minus 1 we are taking common. So minus 1 the whole square, it will be what? 1 only. So it is removed. This is minus b, a minus b plus a the whole square left. So we can write a minus b the whole square and here a minus b the whole square. They both become same. So 2 times of a minus b the whole square, because they both are 2 times and we need to add it. Okay. So we are left with under root 2 and this a minus b square, it will be cancelled. A minus b will be left. Or you understand from here to here, you understand one thing, b minus a the whole square or a minus b the whole square, they both are same. So in place of b minus a, we can write a minus b. Here also BC, this is B and this is C. So B, x2 minus x1 the whole square, y2 minus y1 the whole square. I did the same and I got this thing. And AC, I got this thing. So try to understand. Now we got AB, BC and AC. So let us substitute. AB is what? Root 2 A minus B. AC, BC is what? Root 2 C minus B. And AC, don't write AC now. Taking LHS. Multiply root 2 inside. Root 2 minus A, root 2 B plus root 2 C minus root 2 B. Okay. So what we got from here? So we got root 2A plus root 2B minus root 2b. Minus root 2b is what? Minus 2 root 2b. It will be minus of 2 times of 2 root 2b. Alright. So we see that we are getting AB plus BC as this. And we are getting AC as this. As these two results, they are not coming same. So there is one flaw in our solution. And that flaw is, the AB we found, I haven't rubbed this part, and we got this as AB. So, as I told you that A minus B the whole square and B minus A the whole square, they both are same because we are getting with the identity the same thing. So this is only the flaw. in our question, and we need to just check. Now this a minus b, we are writing this as b minus a. Let us check with b minus a, are we getting the answer or not? So in place of a minus b and a minus b, we are writing b minus a and b minus a. So it will be what? B minus a, and this will also be what? B minus a. So here the thing will be b minus a. Now let us check with this that are we correct or not. See, this is what the flaw, sometimes we have to check these things. So as you can see that root 2b with this root 2b, it will be cancelled. Wait, I have written root 2. We are left with root 2c minus root 2a. Now take root 2 common, c minus a, which is what? ac. So hence now it is proved. Okay, so you just need to keep check here. Okay, similarly, just try to see 17th and 18th question. 17th question, you need to find the value of k, and provided you are given with one condition that the 3 points are collinear. Okay, so as I already told, AB plus BC equal to AC. Use this equation to find the value of k. And in the 18th question, you need to prove that you are given with 3 vertices of a triangle, and you need to prove that these 3 vertices are not the vertices of triangle. If there is no triangle, means there may be a straight line. Alright, if you have to prove that the 3 points are not the vertices of triangle, it is not making a 3-sided structure. That means it is making a straight line, and in the straight line all the 3 points should lie. So what is the hint in this question? You prove that the points are collinear. If you could easily prove these 3 points are collinear, you could prove that they are those 3 points are not the coordinates of the triangle. Alright, so that's it for today, dear students. Just do the questions. I hope you'll do, and if any problem, I'm there to explain. Thank you so much. Have a nice day. Bye bye.